Hello everybody, very good day today. We will continue previous lecture, human error, classification and causes. So, you have seen in my last lecture which is lecture 41, I explained these 4 points that related to production system and then how the deficiencies at across different level is basically from human contribution point of view lead to accident. Then definition of human error was given to you from generic definition to working definition. In this lecture, we will discuss the classification of human error, causes of human errors and bottlenecks and generic error modeling system. Maybe 25 to 30 minutes of time, we will finish this lecture. So, if you recall that in the last class I stopped by giving this example. I said that there is stimulus and then the operator function is there, and finally accordingly based on stimulus operator function ultimately decide the actions which is basically responses, and accordingly we have discussed error in information, error in instruction, error in organization or decision process and error in operation. And with reference to this example we have seen. Now, I will carry forward this example further and we will see some more issues, particularly from classification point of view. Then if I recall my previous lecture, that is lecture 41, we have said to you also that whenever any work is carried out, there is end state which is basically the objective to be achieved. And in order to achieve the objectives or the goal, so a set of series of planned physical or mental activities to be carried out. There can be problem or error in planning, and there can be error or problem in execution. So, if everything planned correctly and executed correctly, you will achieve the desired goal, that is successful work. If you planned correctly but not execute correctly, then what will happen? It is basically execution error, primarily comes under slip and lapse based on the region classification what we have seen in last lecture. Suppose your planning is wrong but executed correctly, then it will be lead to mistakes. And another one is what I have said based on this example, based on this concept, that suppose planning is correct, execution can be done correctly, but intentionally done wrongly, that means not followed the procedure intentionally, that is known to the person who is doing it, that will go to the violation. So, in between successful action and violation, there are human error in terms of slips and lapses and mistakes. So, with this basic framework we will further process or progress. So, here let me repeat this case again. So, you have seen in the accident precursor in the last class, I said that based on reason, this is also we have taken from reason 1990 book. So, based on reason that unsafe acts, when accident takes place, you immediately relate to unsafe acts. There are precursors to unsafe acts Then these precursors are again a result of line management deficiencies, and line management deficiencies also are influenced by the decision makers deficiencies or fallible decisions. Okay. Now, if you investigate any accident and if you found or when you inspect the workplace, you may find out that there are some unsafe acts which are basically the active cause of accident. Okay. So, the unsafe act can be unintended actions, can be intended actions. As I told you, the intended one comes under violation. So, SOP is created so that the people know that what to be done, when to be done, how to be done, all those things are there. Suppose you are not following those, then there will be violations. SOP is violated, it may be routine violation, exceptional violations, act or of sabotage, etc. So, that means one and violations. So, when it is unintended, unsafe act is unintended. If unsafe act is intended, it is violation. If unsafe act is unintended, then you see slip, lapse and mistake. So, here basic error types, that is why slip, lapse and mistake, and I have given you that when slip, when lapse and when mistake. Inadvertently pushing wrong button is slip. Deliberately failing to follow procedure is intention, and press a wrong button is mistake, because in the planning itself you have said press the button which was wrong, so that is mistake. But suppose the wrongly, when it was not as planned, so that during execution time suddenly inadvertently if you push wrong button, that will lead to slip. So, now slip takes place because of attention problem. Last class I showed slip and lapse, but we have not differentiated the two in that manner. So, attention problem leads to slip, memory failures lead to lapse. So, intrusion, omission, reversal, misordering, mismatching, these are all coming under attention problem. Omitting planned items, place, losing, forgetting, all those things are coming under lapse. Okay. And then when you are talking about mistakes, then Rasmussen has given 3 performance levels. One is skill based, another one is rule based and knowledge based. So, there can be rule based mistakes, there can be knowledge based mistakes. But and if we talk about the slip and lapse, these basically primarily at the skill level. So, you see Rasmussen classification what happened again. So, there will be some routine jobs which maybe you are doing regularly, and other way I can say it is almost habitual that you have to do these things, and accordingly you develop skill, and whenever given that work you are doing it. So, in that skill level work, slip and lapses can take place. But when it is rule or knowledge based, rule means there are some kind of if then rules. Do this, if condition this, do this, condition this, do this. Some if then rules are set. Then what happened? The rule may be incorrect, not planned properly. So, rule based mistakes will be there. Knowledge based mistake mean it is not rule, because there is no set rules that by which you will do. It is basically your total knowledge will decide. Given the situation, you process based on your experience and knowledge and take decision and do the and take actions. So then that will be knowledge based mistakes. So if I say decision maker, line management, they are primarily will be the knowledge based mistakes. Okay, so maybe the supervisor or at the line management, means line management level there can be rule based mistake also, but a worker level there can be rule skill or there may be primarily skill based work. Now a rule based work, if you do suppose a particular work with the same set of rules you are doing several years, so then finally it will be converted to skill. Okay. So that's why not only the sleep, lapse and mistake, you also require to know whether the activity is a skill based activity or rule based activity or knowledge based activity. And then that means first level task classify skill based task, rule based task, knowledge based task, and then see that what kind of error that occurs. If it is skill based, usually slip and lapse will be occurring. If it is rule based or knowledge based, there will be mistakes and violations, you know. Okay. Now, in order to understand little better manner, because how when human is involved, so there is another concept called operator action tree. It is something like event tree diagram is developed to further stress on the classification, so that you will be able to do it and identify the errors. What kind of errors? What is this classification? This is some event occurs, then the what human will your work, you have to detect that event occurs. After detection, you diagnose that what it is, and based on diagnosis you take action or response. Then what will happen? Depending on action, there will be recovery or no recovery situation, and finally that failure will take place. Okay. So abnormal event occurs. This is the first page. For example, power transmission failure, loss of water to heat exchanger, in our case overpressure condition in the pressure tank example. So how do you know abnormal? In event occurs, suppose alarm sounds, because this is an indication of abnormal event, that overpressure condition. Then what is this is, then you have to detect it. Operator see the pressure gauge. So detection deviant instrument readings. Pressure gauge says yes, overpressure condition has taken. Pressure gauge, there is deviation from the normal. Now diagnosis, the operator will, after seeing the reading, he should diagnose what should be the response to be taken. So there can be diagnosis problem by the operator, and then or he diagnose it fully that yes, it is overpressure situation, then he ultimately close the pump means open the contact. So this is my, given the abnormal situation, this is the successful one, this is success. Okay. Now what happen? Alarm sounds and ultimately detection is not done. This situation, this is non-response. Why detection is not done? That depend whether it is non-response, it is because of violation or because of any mistake, but ultimately these are the things to be done. So, in between you find out there is mistake, there is slip and lapse, okay, and another term we will be using here which is recover. So, what is diagnosis? Diagnosis is assess the situation, identify planned response and determine actions. So, what diagnosis it will be? Pressure gauge shows that it is basically beyond the limit. Okay. So, what diagnosis that mean diagnosis means you have to open the contact. Suppose operator failed to open the contact because he thought that that operator will be timed out soon, and whatever excess pressure is there that will be released by relief valve. Okay, that situation may happen. So, what happened when the diagnosis is successful, but the action was not taken? Means contact was not made open. So, in that case, if relief valve works, pressure will be released, and suppose timer at that time also get disconnected, then recovered. But if that will not happen, ultimately lead to overpressure situation, and which ultimately maybe after some time it will lead to tank rupture, but this is that means actually recovery has taken place even though wrong action is taken place. Another one wrong actions, no recovery, that is slip and lapse. So, let me repeat again. If first is alarm sounds, pressure gauge, alarm, pressure gauge successful, diagnosis successful, then response is contact open, success. So, here response or diagnosis successful, contact is not open, that means action is not taken correctly. So, in that case what happened, if relief valve works, timer timed out also maybe within that minutes, then recovery. Another one, action not taken, no recovery, it lead to, it is basically slips and falls, lapse and slip. Now, diagnosis is not taken, failure, diagnosis failed. So, even in that case what happened, the relief valve and timer relief valve release the pressure and timer may get disconnected. In that case again another recovery will take place. Suppose that recovery will not take place, then it is the mistake. So, diagnosis is failed. That means these are the steps to be carried out, but during diagnosis failure has taken place. That means there is diagnosis, that procedure, the planned steps was not, correct steps was not there. So, it is a mistake, other one is response. So, this is what is the classification. This one we have taken developed by this IAEA 1991, and it is given in Kumamoto Henley. We have taken from Kumamoto and Henley. This is a better one from execution point of view, because the engineers will be interested in this. Slip, lapse and mistake and all those things, the definition is one, and here basically this is the actually what will happen during that time, what are the actions to be taken, from that point of view it is given. So, it basically help you to do the work in a better manner, because engineering point of view. Okay. But none of them are basically inferior to other. They are complementary to each other, and the sleep labs mistake classification, that from the psychology point of view, the how brain works, that point of view, and this one basically more working point of view. Okay. So, nevertheless, we will use both the concepts, and we will try to take one which one most suited to the given conditions, given work. Then I will come to the that why these kind of errors occur. Broadly, individual, organization and safety culture are responsible for this. Now, what are the individual factors, what are the organization factor, how safety culture will ultimately lead to this kind of errors or erroneous situations, that there are a lot of literature available, and you will find out a plenty of factors in many, in fact, in performance we will be discussing later performance shaping factors. So, there we will discuss further. Here basically that from, as we are dealing more on the that sleep, lapse, mistakes, those point of view. So, we will discuss little bit of brain bottlenecks here. This one I have taken from this book Kumamoto and Henle, and there they have basically given the human and computer analogy, that there is short memory, long term memory. So, there is old CPU and new CPU. CPU means central processing unit, and new CPU is basically the short term memory, and there it is given that the new CPU is the problematic one, and it creates lot of problem, means from the human error occurrence point of view, it has the maximum contribution. Okay. So, in then they have described the brain bottlenecks. I will just read out the brain bottlenecks here, because it is impossible to give each and every case the example, but these descriptions are simple. So, you will be able to understand it, and given a case you just find out what actually happened and accordingly take the actions. First one is shortcut, that is brain bottleneck. What does it mean? Simplification of things to reduce workload. For example, I can tell you, suppose when alarm sounds, the operator see the pressure gauge and then contact should be opened. Suppose this is the SOP. So, and you think that okay, why should I see the pressure gauge, alarm sounds? So, obviously there is over pressure, then you open the contact. So, what will happen? Ultimately tank will be charged with gas, but below the desired level of pressure. Then procedural step or system element irrelevant to execution of task are discarded. System element irrelevant to execution of task are discarded. So, okay, some steps, some elements may apparently maybe you are thinking that it is not relevant. So, you started discarding because to save time. Protection devices or safety related procedures are always neglected. You assume that okay, protection is there, it is working. For example, in case of burn injury, so there is one that mitigation mechanism is, there will be the shower. So, immediately the person, any kind of burn, you will be put under the shower, and this is a protection device. Or let it be the working near the welding machine, so the eye protection. So, many a times what happened, those protection devices and these are neglected. So, that ultimately then resulting into safety problems. So, shortcut is one of the brain bottleneck we use to do it. Second one is perseverance, believing an explanation that fits the current situation, okay, that fits the current situation. So, given a situation, you have several explanation, but you believe, you have a particular belief, okay, the student, suppose the student is absent to the class, then you as a teacher, if you believe that he was definitely sleeping, and then accordingly you take actions, but actually it may be a medical reason, because he is not feeling good, but even though he has come to the class. So, that means other possible reasons you will forget, you will simply believe that this explanation fits several times, so it is the explanation. That is basically perseverance. Third one is task fixation. People preoccupied with one particular task because of task prioritization leads to ignorance of other important tasks. So, so that it is, as I told you, that the entire end goal objective will be achieved only when you will basically do all the task. Activities given to you, task can be further broken down into activities also. Now, what I mean, but you like some task, or you give priority to that task, and you start doing that one what you like, or what you, then accordingly you prioritize. So, and then you neglect the other important tasks. So, ultimately that also lead to your human error. Then alteration, engineer constantly changes decision while basic information is not changing, which leads to unavailability of systematic responses. This is a interesting one. Please see, you are not getting the suppose desired result, you change decision while basic information is not changing, you have not collected any further information. You are taking decision based on previous or old information, and you are again changing it without collecting other information. So, what will happen? Ultimately, you will land into wrong decision making. Then dependencies, excessive dependencies on other personnel, on routine procedure, at automatic controllers, indicators are sometimes harmful. Suppose alarm sounds, that means over pressure, but alarm can be erroneous, false alarm, spurious alarm. So, you should not be dependent on alarm only, because you are giving another steps, check the pressure gauge. So, there is possibility of both failing is much less. But you have seen earlier that okay, whenever alarm sounds, you found out of 100 times you have observed, and you found out that 95 times it works, or 99 times it works. So, you are dependent on it. In that case, overpressure condition can be protected, but under pressure cannot. The naivety, humans when trained tend to perform tasks bypassing the new CPU, that is basically short term memory, as I told you. What does it mean basically? Basically that you have, suppose you are trained to do something, and long back you done, it has gone to your, let it be long term memory lately, but new information comes, you have ignored that new information, you have simply because of your, based on your previous training what is there, you started doing this. In that case, this is because thought process is occupied with inductive logic and probability, which more often fails non-stationary and planned emergencies. Then queuing and escape. It is happening to me now because I have so many work. So, what I am doing, as I am not able to cope up with this load, what I am doing, I am saying okay, save this work or write down some piece of paper, we will do later. That is basically you are making the queue of the work, and ultimately you are not doing, you are escaping. So, this occur when workload is too high. So, this is the precursor to workload. High workload is precursor to unsafe acts. So, you are not doing it, you are basically queuing it and escaping it. Then gross discrimination, neglecting detailed information, qualitative rather quantitative information is collected, because quantitative information collection is a difficult one, time consuming one, because there is a measurement involved. So, better you ask some people some information, some qualitative information you will get, and then what happen, accordingly you take actions. So, that will also lead to human error. Cheating and lying, no need of explanation. What is cheating and lying? So when you analyze human error, when you analyze accident due to human error, then suppose you want to also find out that how to recover from those errors, then this brain bottlenecks, if you analyze and finally you are able to link to this, then perhaps your analysis will be, not perhaps, definitely your analysis will be much stronger. Then another important classification here, that is in terms of error tendencies, which is basically given by Reason 1998, that he found out that what are the how human proneness to error, that is the tendency to commit error. Similarity bias. Similarity bias, we used to face this problem, because if we find that similar situation and which can be explained with earlier case, some matching is possible, then we consider that okay, so this is the reason. So, but it may not be the reason may be something different. So, when we basically diagnose something, that as soon as we get some matching with the previous experience, we say yes, this is the case. So, this is known as similarity bias. Frequency bias is which happens many a times. Suppose we match with how many times that the similar situation occur. If the highest probability one we will consider. So, it may be the case, a unique case, which is not having any previous occurrences. So, in that case you will face problem. This is basically the pattern matching. First one is pattern matching, second one is highest probability, high frequency, third one is bounded rationality. People have only limited mental resources for diagnosis. Because of this, because you given a situation, I will ask you, if we said that okay, you tell what are the possible ways it can happen, and you will find out that after one or two you have nothing more to say why it is happened. There are some people who can tell 10 different ways that this may happen, but there are many who basically after one or two your that memory, that means resource is exhausted. That means that is bounded rationality. You are rational, but your knowledge, your mental process, diagnosis process, your resource, total resource is limited. Imperfect rationality. People rarely make diagnosis according to statistical decision theory, logic, etc. Okay. And in fact, if you try to tell that okay, what is the evidence, then people will say everything cannot be judged by evidence. This happens like this. You prove imperfect irrational thing to rational also sometimes. Then reluctant rationality. People perform diagnosis that minimizes conscious thinking. You do not want to tax your brain. Why unnecessarily putting lot of things in the brain and when you are diagnosis. So, you want to minimize the cognitive load. So, then that will be reluctant rationality. Incomplete and incorrect knowledge. So, even if you see all the engineering that concepts, not concept, all the engineering applications side, when we basically talk about many of the concepts we basically discussed. For example, elasticity, suppose we are behavior of, for example, roof fall. In underground mine, roof fall takes place. So, the roof behavior, that one we want to judge, but we do not have complete knowledge of roof behavior. We have some theories like elastic the model, elastoplastic model, but they are basically, they are not the exact reality, they are approximation of the reality. So, approximation of the reality means there is incompleteness, incorrectness. So, that also lead to human error. Okay. So, after this I will just finish today's lecture with this generic error modeling system developed by Reason. So, in fact, I have taken from his book Reason 1990. So, here interestingly that the skill, knowledge and rule based task as well as the sleep lapse and mistake, that both are combined together, and then when it is skill based work, then sleep and sleep and mistake lapses can take place, rule based mistakes and knowledge based mistakes. So, how do you basically model the human error with this classification, and when you say it is rule based mistake, when you say it is sleep and lapse, when you say it is knowledge based mistake. So, this broad modeling framework is given by Reason. So, when we say it is skill based, then basically it is the routine actions, routine things you are doing and every day, and ultimately it is converted to, when it is a skill means given a time you can do, any time you can do this, that is why it is skill. You have the skill, given that work you will be able to do it. And we have seen that in the skill based case, previously I have given you that there are two kinds of problem, one is attention problem, another one is memory problem. So, given the routine action in familiar environment, then you are asking that attentional check on progress of actions. Is there attention problem? If it is, then it is okay or not. Okay. So, attentional checks on progress of actions, is attentional check taken place? So, if it is okay, then ultimately the goal state is there. So, that means routine work, attention work and memory lapse of type of work, that you first check, and if the attention lapse, all those things takes place. So, then you are understanding that attentional check on progress of action, yes, that okay. Then if it is not, that no, then what will happen? There is a problem. Means when you are not able to relate these routine actions with attention and lapse, memory problem. So, then what is required? There is higher level problem. So, this problem, when you analyze, consider local state information. Is the pattern familiar? If then rule is there, is the pattern familiar? So, you analyze this with the local information, and are you able to find out some kind of patterns. If there is a pattern, then ultimately there will be some stored rules. Because of different patterns, rules are given. Okay, in fact, we have discussed safety ontology much earlier, where we have derived certain patterns. If this, then this, then this is going to happen. Suppose when you are analyzing, then you are able to find out that similar pattern. When your activities or task you are performing, you are able to find this pattern. Then you apply that rule. That rule, if the problem is solved, then you go to goal state. And after applying the rule, suppose the problem is not solved, then you again check the problem. Okay. Now, what will happen here when after analyzing the problem with local information, suppose you are finding out that there is no pattern. One is there is pattern, there is no pattern. So, when there is no pattern, no rule can be framed. So, it is a issue of knowledge base. So, then you recall, is there any other higher level analogy which can be applied here, and then some rule can be generated, some pattern can be identified. So, this lead to this. So, if there is some analogy found, again that rule can be extracted and you will be applying. If problem solved, finds, otherwise again you repeat this. But suppose there is no higher level analogy which is available to you, so then you say none found, and in that case it is purely your knowledge will work. Revert to mental model of the problem space, analyze more abstract relation between structure and function, and then infer diagnosis, formulate corrective actions like this, and this is your ultimately this again is the problem solved. If not, go to problem and repeat this, and subsequent attempts, in between attempts will be there. Okay. Very abstract way I have described this without any proper case with this case, because this kind of case development is a time consuming task also, and our sole purpose is to give you this information, and with those information or those techniques or the modeling concept, you will be able to use it in future, and that is our belief and our expectation from you also. And I must say that this is the book which I rely on for this lecture as well as this previous lecture heavily, and I have taken material from this book while understanding the concepts also. Then this is another that paper published in Reliability, which also we have used, and in addition I have read all those papers like Marvinder's and this book also, as well as our own paper from there also we have gathered some information. But mostly if you ask me, but that this present lecture as well as the previous lecture, I will tell you that please go through this book, the relevant chapters, and go through this with the relevant chapter with this paper, and I hope that you will be able to understand the concepts and the theoretical underpinning what we have done here for human error. So, in next few classes we will go into more engineering way of understanding, identifying and quantifying human errors, and the psychological part is also very important when we are talking about human error, but we want to identify human error, quantify human error, and at the same time we want to prevent that human error should not occur, and we will more rely on the engineering intervention of engineering way of doing things, and accordingly we will also discuss human reliability analysis in some of the lectures. Thank you for listening.